Welcome back, and day 7 of 8. And today we're going to start off with, we're in basically exam domain number 5. And we're going to start off with section 5.1, which is troubleshooting methodology. Now, the first thing that we're going to cover, and this is something you're definitely going to want to memorize, is CompTIA's troubleshooting methodology steps. Before you fight the urge about these, like, well, it's like 5-minute abs. How about if I put out 3-minute abs? Yeah, so that pretty much once you get out in the field or in your job, your organization is going to have their methodology that they want you to implement, and you should implement that. But a huge part of getting to a problem, documenting what you did to get there so that other technicians can go to your ticketing system, which you'll probably be working with, and research anything that's happened in the past, and maybe policy's been built around how to fix that particular problem in your organization. That is all actually captured if you follow the CompTIA 6 steps. For your exam, at a bare minimum, you need to memorize these steps and the order in which they occur. Now, it's a little silly, I know, but I just have a little dumb song I say, which is IETEVD, 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 VD, wrong one. And so what you can do is you can get to the exam on that pad of paper that they give you. It's like a laminated board. Is my caps lock on? And you get that laminated board, and you can just say IETEVD, and then you can even take some time, and you can say, okay, once you get those down, you can say, all right, what's I again? Identify the problem. All right, and then you could say, what's E again? So there's 2 E's, but what's that first one? And then you can kind of use your common sense. Even if you remember them both and put them out of order, you go, well, you got to establish a theory. And then T, what's the third one? Well, that's test your theory. And then what's E? And then I'll get rid of some of these spaces. It's not important that it's neat. This is just something you're handwriting with the grease pencil that they give you on the laminated board when you sit down. There's several things that you're going to want to do with this. So as you go on, I'm just following these here, but by memorizing the order of the first letter of each one, and then getting into the exam, sitting down with that grease pencil and writing them down, there is a very good chance that you're going to get some question right. They're going to want you to know which order they're in and know what they are. So the next one, establish a plan of action. And you can even say establish plan of action. You know, you can shortcut. Doesn't matter if you misspell it like I just did. Oops, misspelled that. And then after you establish a plan of action, what's next? You need to verify system functionality. And then last but not least, document everything that was involved. Document what you did, make sure you capture all of the important aspects of what happened. So that just going in there, IETEVD. Walk in there, you're all like, you're showing your ID, you're giving them your stuff, you're putting everything in the locker. IETEVD, IETEVD. And they're thinking you're a weirdo. You sit down, thank you for the grease pencil. Yes, true. Thank you, sit down. IETEVD. That will probably get you at least one question, and you can refer to the order of those things, and that will possibly get you more. I feel like there is a good percentage of questions around this domain and a good amount of questions around the laser printing process. Don't know why, but that's it. Now, taking a step back in real life, it is utterly important in IT. And the longer you're in IT, the more you will appreciate this, to have policies and procedures that multiple people can follow. So I've been like the IT guy in my own businesses, and I don't have to worry about some of the documentation aspects for as far as sharing that information with other techs, because there are no other techs. It's just me in that situation. But I've also been part of a team that uses a trouble ticketing system, and there's several software ticketing systems. Almost certainly, if you're in this class, you'll be either working with one in the future or you're working with one now. And you get a ticket and you read the ticket and you begin whatever the process is. And in that case, the fact that there is a formalized 6-step process that you do perform certain actions and activities within each of those steps allows for other technicians who may be brought into a problem to see what you've done, and you're speaking the same language. Even if you in your ticketing system, they have, like, you have a ticket and they may have the 6 steps and they may have a place for notes under each one. That it may be that formalized. They may collapse some of the steps. For example, in the field, I would tend to collapse step 3 and 4. So when if I go in, identify the problem, the monitor's not working. I establish a theory, it's unplugged. I test the theory, yep, it's unplugged. I plug it in. I'm testing the theory and establishing a plan of action at the same time. So I'm not going to say, like, stop and go, I believe that the plug is unplugged on the monitor. I have checked and verified that the plug was unplugged. My plan of action is to plug it in. Like, that's exag. But if I have a ticketing system that's exactly adhering to the troubleshooting methodology, then I will do that. Test my theory, thought the monitor was lacking power, checked the plug, saw that the plug was unplugged, established plan of action, plug it in, verify system functionality, verify that the monitor is now displaying everything and it's working, and then document what I did. So these 6 steps are super important for the exam. They are incredibly important if you're brand new and you happen to work in an organization that's like, we use the CompTIA troubleshooting methodology 6 steps. Nothing wrong with that. Awesome. I know what they are. I passed the test, and I'll use those. If you're just brand new and you're working in a little bit of a loosey-goosey environment that's never even addressed this type of thing, now you're coming in and you're saying, okay, I'm just going to identify the problem. I'm going to establish a theory. I'm going to test the theory, establish a plan of action, verify system functionality when I'm done, and document the solution. And you have a guidance. For the exam, this is what you need. Before you dive into any actual issue or any problem as somebody who works in IT, it's incredibly important that you either have access to or that you just thoroughly understand the organization's policies and procedures. And so, for example, I've worked a lot in the Microsoft 365, Office 365 space. And I've worked on really small companies that the managers rely on their IT people that they hire out. They subcontract out an IT staff. They don't have an on-premises IT staff. And they're more than power users. They're the administrators in their tenancy. They create users. They assign licenses to users and things like that. When there's a problem, they'll contact IT because they're paying for IT consulting, and so they try and solve it themselves. But I've also worked in larger organizations where there's a dedicated Microsoft 365 admin team. And a person who's in charge of changing out hard drives in the data center, upgrading the memory on the servers, racking servers, repairing PCs on the floor for the sales staff, repairing and replacing monitors. You know, that level of IT person doing trouble tickets for problems with the PC. In those scenarios, those particular we call that level 1 support, even though some of those people are really, really skilled at their job. But tier 1 support, level 1 support. And then it wasn't just tier 2 support in some of the larger organizations I worked at. It was the tier 2 security team, or the tier 2 Microsoft 365 team, or the tier 2 database team, or the tier 2 development team. So like there was the level 1 that was basically sent out to do repairs on physical hardware on devices people use day to day. And then level tier 2 was siloed on some of the larger organizations that I've had the privilege of working with. And so in those organizations, it would be a no-no, okay, for the tier 1 tech to go, hey, I think there's a problem with the DNS settings for our email up in Microsoft 365. First off, they wouldn't be allowed to, hopefully, from permissions to do this, but it would be out of scope for that level 1 technician to go sign in to the company's DNS and make some changes to the DNS records on the public internet. They may actually be fixing the problem. That may actually solve the problem. But there would be a process in place that said, look, activities like that, we just have to have our Microsoft 365 team do it because it's under their domain of responsibility, and we can't have people affecting change that they don't know about that affects and falls under their domain of responsibility. So as I'm teaching this module, I just would like to start off by saying, I get it. If you're in a scenario where you don't exactly follow that, it makes sense. Follow whatever is right for your situation at the job you're working on. For the exam, we want to pretend like every company is following this exact methodology. We want to know the order of the steps, IETEVD. And then we want to know what goes on in each of the steps. So if we're asked, like, for example, if we're asked at what point in the 6 steps do we escalate the issue to a higher level of support? Is that during test the theory or establish a plan of action? So we want to be able to know where in which of those. So we're going to talk about each of these. But the very first out the gate, before you even jump into a problem, have either a very thorough understanding of what you're allowed to do and not allowed to do, or have access to either somebody, some group, some internal forum, or some documentation that tells you what you're allowed to do or not to do. For example, just one more example, you may have a budget. You may be on the team that is able to replace hardware, and you may have a budget that says, look, the following things you can just do. You can upgrade memory up to X amount of gigabytes. You can swap out hard disk drives on laptops or workstations with solid state drives. We're moving to that anyways. You can buy new monitors. You can replace monitors. You can buy the following cables. You can spend on the IT service account up to, $150 without authorization for the following category of components. How did they put that category of components together? Well, most likely somebody had done it before and started, but then by following these steps or something like it, they were able to capture all the tickets, categorize what the tickets were, and rather than frustrate the users with like someone going to their desk and going, oh, the cable's bad, like, well, I'm pretty sure your cable's bad, but in order to get a new cable, I got to wait till Monday's IT meeting. So good luck. Instead of that, they could just go, cable's bad. I verified the cable's bad, tested with the known good cable. Everything worked. I need to replace the cable. I know that I'm authorized under corporate policies to replace cables. I was able to either buy one, have it overnighted, go to the store and get one, or go to the IT hardware room, grab a cable, document that I did that, swap it out with the BAP, whatever the corporate policies are. Always consider corporate and organizational policies. Now, let's dig in. IET, EVD, IET, EVD, whatever works for you. I know you'll look like a psycho going in to the testing center, but I promise you won't be the first one with some sort of singing the acronym. Step one, identify the problem. What's going on? You know, what's happening? Now, if you've ever dealt with any serious health issue, or if you've dealt, with, police or things like that, good bedside manner goes a very long way. If your ticket, if your troubleshooting involves a user, which it probably does, man, just be nice. There's nothing worse, nothing worse of a feeling than interacting with an IT person that when they leave, they made you feel dumb. Like, oh God, create shortcut. God, are you serious? You don't know how to create a shortcut? Like, no, I don't know how to create a shortcut. I don't even know what a shortcut is. I'm in charge of this machine right here that manufactures 650,000 widgets that pays your salary. Can you just create the shortcut? Oh, creating a shortcut. Okay, so what you do is you right click on the program and there's an option usually you kind of look for, it says create shortcut. And if you click that, it will basically create an icon on your desktop that will be easier to find the program. Sometimes I can't find it either. I do that. I try not to get exaggerated with creating shortcuts because then my whole screen looks like a wallpaper of shortcuts and sort of defeats the purpose. But yeah, I find it to be useful. And I remember when I learned how to do it, I was like, really, you could do that? So that, just be friendly. I mean, and definitely don't come in with a bunch of technical jargon. You're there to identify the problem. And if you're dealing with a user, then they can give you a ton of information. Hey, what's going on? Yeah, I saw your ticket. Your monitor's not working, huh? Okay. Let me ask you a couple questions if you don't mind. Like, was it working yesterday? Okay, good. Was it working today? So like I said, if you've interacted with medical professionals for a health issue, which I hope none of you have. Unfortunately, I've dealt with that in my life. Not for me, but for family members, and well, for me too. But man, it's really, really helpful if the person's the doctor, the policeman, whatever, you as an IT person, you're just nice and understanding and empathetic. And this is not an IT professional. This is someone who's relying on you. So remember that they are not expected to have any knowledge whatsoever. They don't know what CompTIA is. They don't know what a NIC is, a network interface card. They don't know what an IP address is. That's like, it's all like, whoa, sounds crazy. So keep that in mind. Now, you're interacting with the user. You're trying to identify the problem. Keep in mind, in IT, and sometimes it's not so obvious, okay? Sometimes the problem is not what appears to be the problem, okay? So you may be seeing what the user's describing as a problem, but it's actually a symptom of the problem, if that makes sense. So you want to identify as an IT person the problem, and the symptoms of the problem will help lead you to the problem. And you want to, listen. You want to be an active listener, and you want to be really nice and really friendly, and you really want to listen. The users will give you great information. Now, keeping in mind that people we're dealing with probably not, most likely are not highly technical people. You may get some information back that you sort of have to discern through the non-IT listening skills. For example, if they're all, well, the internet's down. And you're thinking like, the internet is a series of of local area networks connected by a backbone. you're like, well, I don't think the internet's down because I got the ticket on the email, which came through the internet. But you don't indicate to them that you're thinking that. You're realizing like, well, what they mean is what they want to do interacting with the browser isn't working for them. So this is like, believe it or not, I'm sure most of you in this class have encountered something like that. I think the internet's down. And that can mean like nobody can get to the internet, or they can get to every site on the internet, but where they need to upload a file, an application that they're trying to access, the login's not working. So you just need to be a very active listener, and you need to be friendly and empathetic, and you're gathering the information. Other information that you may be able to gather as an IT pro is looking at any type of alerts or notifications. One super helpful thing are error codes. So if the user gets an error code, it's error code 0x53924, they just close the window. You can help with that by training people to take screenshots of error codes, because it's incredibly helpful. Now, probably most of us know how to do screenshots. Like I could hit the Windows key, type snipping, and I know that the snipping tool is built in, and I can say, okay, I can say new, do a screenshot, and now I have a screenshot. I know how to do that. I do that probably 30 times a day in my job. But your average user may not know how to do that. There's a couple shortcuts I know on my Mac. I could do a shortcut to do a screenshot. But having on an onboarding training, teaching people like, hey, if you see an error code, if you remember, no big deal if you don't, by the way, but if you remember, just do this, do a screenshot. It can really help the IT team save it to your desktop or documents, whatever. But gathering that information, and then in a non-accusatory fashion, trying to find out if the users made any changes, like, oh, okay, so this, it was working yesterday, okay, and then did you do anything today? Like, for example, did you move your monitor? Now, in a scenario where the monitor is just off, by any chance, did you move your monitor or anything like that? And they're all like, yeah, actually, there was a bump on the desk from something, and so I did move the monitor actually. And you're like, okay, yeah, cool, God. And just be empathetic. Like, oh yeah, that would drive me crazy if it was crooked. That was a good decision. All right, thank you. And know, as an IT person, know if any changes were made in IT. Know that. Also, if there is documentation in your ticketing system, before you even go to interact with the user, take the time to search your system for the symptoms that have been reported, and see if you have any of that information, or see if in this ticket, if you're not the first person to visit this person. And one of the things that I encountered, again, not in IT, but I think it's directly related to this scenario, is unfortunately my wife had some health issues, and we were seeing a series of doctors. They were coming in, she was in the hospital, they were coming in over and over, like doctor after doctor after doctor. And each doctor, I had to like repeat the same story. Like, okay, then this happened, then we went here, then this happened, and this and this. And by like the 7th doctor, I was like, excuse me, she doesn't have a chart? And they're all, oh yeah, I'm all, did you read it before you came in here? And it was like this moment. They're like, no. I'm all, man, I've been over this like 8 times today. Like, it's really harrowing and uncomfortable to even talk about. Would you mind just reading your chart and come back in and then ask me any questions that aren't answered on the chart? Because that's it. So I always remember that in IT and think, yeah, make sure to read the documentation on the ticket, see what's already been done, see what interactions. Because you'll feel right away if you feel hostility from the user. You can kind of tell if they don't feel that they've been listened to, if they don't feel that their problem's been solved, usually, and if they've dealt with maybe an IT person that was a little bit condescending. Don't be that person. But you can identify the problem, interact with the user, find out what's going on, see if there's any changes made by the user, any changes made by IT. Okay, and whatever you do, before you do anything, if possible, back up whatever system you're on and whatever state that you're in. You don't need to do a SQL Server database backup on a workstation if their monitor is not working at that point in time. So be, within reason. But if you walk over there and I turned on my computer this morning, I heard a grinding noise. You're like, hi, what we're going to do is we're just real quickly going to capture an image of your system. If you just give me 30 minutes, because we just want to make sure no matter what happens that we capture all your data, your documents, photos, whatever you got on there, we're going to capture that. Now, hopefully you're working in a scenario where that backup's automatically happening anyways. But as in the CompTIA troubleshooting methodology, identify the problem, if necessary and reasonable, perform backups to a system. All right, so that's step one, identify the problem. Step two, establish a theory. Okay, so you'll get better at this the longer you're in IT and the more problems you run into and the more you go to establish a theory and you were wrong. Being wrong is a learning opportunity. Okay, so that's the other thing. When I establish a theory, even if I'm almost 100% positive that I've got it, when I'm around my users, I will still open the door to, I think it's probably this, but I need to make sure. Also, in troubleshooting, remember, what you may be fixing may be a symptom, not the actual root cause of an issue, but you have to deal with what's at hand, right? So establish a theory. And in your theory, to keep it simple, like the user moved the monitor, they relocated the monitor. I've done that before. When I did that, the power cord that's inserted in the monitor got yanked a little bit, and even though they're usually seated pretty well, I've accidentally pulled it out and lost that. So my theory is going to be, I bet the connector to the power cord on the monitor got pulled out when they were moving their monitor. You still probably want to check to see if it's plugged into the wall, right? Maybe the outlet on the wall lost power. That's possible too. But you're like, I'm going to go ahead and say that I think it's that. And you may need to conduct research. It may not be that simple of a problem, okay? I live in Arizona. I work in Arizona. My business was in Arizona for when I have my consulting business. During certain times of the year, June, July, we have monsoons. There are lightning events that look like a strobe light. And, you go home for the night and a lightning event happens. You come in the morning and somebody's monitor doesn't work. Maybe it was plugged into an outlet and there was a lightning event. Like, just being aware of that, establishing a theory. Well, there's a big lightning storm last night. I'm wondering if maybe that monitor is fried. Is it plugged into a UPS, whatever it is? So establish a theory. If you get error codes, search engines are your friend. Make sure that you rely on reputable sites, the vendor sites. Like if you're dealing with Windows, trust the issue. Trust that you go to the sites like Microsoft.com or learn.microsoft.com. Be careful with, there's a lot of organizations that have websites that do have like knowledge bases, and they have search engine experts, and basically what they're trying to do is like get you to land on them with a common error, and then to get the answer have to pay for it or something. So I just usually like go, is it Microsoft.com? Because they have either their official forums or their actual website for Microsoft stuff is usually really good, especially with the error codes. Most of them are documented. So that's something that you can help with. And also remember, you can research your own ticketing system. So establish a theory based on the information that you got after you identified the problem, consulting the user, logs, any research that you had. You figure out, I think this is what's wrong. Establish a theory. At that point, you test your theory. So in the simple solution of the monitor being unplugged, you plug it back in. Did it turn the monitor on? Yes, it did. I have had scenarios where the problem was the input on the monitor. When someone moved it, they hit, some monitors have these little buttons on them. They hit it and changed the input where their computer was plugged into a VGA input, and they changed it to HDMI or something like that. So the monitor was fine, the computer was fine, the cable was fine. They just accidentally switched to different inputs. So if you have 3 inputs, if the computer's plugged in here and the monitor input is on that one, they'll get the screen on the computer. But if they push the button and it goes over here, nothing's plugged into it, they'll generally get no signal. It will say no signal and usually will give you the port. So that's a kind of a very simple thing that you'd probably be able to figure out really quickly. So test the theory and be methodical and test one thing at a time. One of the things that we have to always keep in mind in IT is every action has a reaction, right? So our fix for one problem, it may fix that problem. And if it's a scenario I was talking about where that's actually a symptom of another problem, it may make 8 other things worse. Okay, we run into this as a programmer all the time where you're like, all right, I updated that function. That's why they write tests, to make sure your code fix didn't break everything else in the application. But that is what we're talking about. So test the theory, identify the problem, establish a theory, test the theory, IET. Okay. Now, if your organization is one of the ones like I talked about, where you're like, oh, you're testing the theory and you realize like, hey, they're not getting their email from Exchange Online. That's a Microsoft 365 problem. It's probably a DNS issue. We need to check on that. And you're in the scenario where all that stuff's handled by the Microsoft 365 team. Then at that point in time, you need to escalate to the proper team if that's an architecture that you have. So this would be where you escalate. So it's in the test the theory part of the process where you would determine like that's where, if needed, if it's appropriate, you would escalate the problem. The next one is a plan of action, a detailed plan of action, and really try and consider the impact that your plan of action will have on any other area, as much as you can. Now, when you look at the plan of action, whoops, I went one too many. Get back here. I'm trying to zoom in. Oh, I didn't have Zoom it running. All right, I will fix that. And we should get this. Let me move out of the way. After implementing the fix, oh, that's the next one. Nope, I'm one ahead. I apologize. Hey, get back there. Establish a plan of action. There we go. Am I out of the way? There we go. A lot of times in my experience for simple problems, when you were testing your theory, it did fix the issue. But some other areas and more complex issues, especially if what you're fixing turns out to be a symptom, not the actual root cause, then you may have to take additional planning, and you want to be careful with that. And these are the things to consider. What is the potential impact of your solution? Will it introduce downtime? Okay. So what about the importance of the issue? Can it wait till the workday's over? Is there a time when being down for that particular product, they could be down? If you have, for example, you walk over and the person's like, yeah, I just went on a sales trip and I'm working out of the office today. I know the weekend's coming up, but I dropped my laptop and the display cracked. You're like, oh, I got to replace that whole monitor. I got to replace the laptop monitor. But for today, maybe a workaround is you just have them temporarily use an external monitor, plug in USB. Hey, use this for today. I got it on the ticket. When you go home tonight, we'll grab your laptop. We'll have the team replace that over the weekend. Or hey, I ordered the part and it's going to come in Wednesday. So if you're working out of the office till then, if you don't need a backup, you're not going on any sales trips, we'll just work with this external monitor. Everything else is working fine. Please don't touch the screen. And we'll get that replaced out on Thursday. We'll have it scheduled. It doesn't actually take us that long to replace. That's a field replaceable unit on this laptop, but we got to wait till it comes in. That type of thing. And generally, it's a good idea to consult vendor documentation. I will move out of the way before making changes to a system. Okay, so that's going to be something. Establish a plan of action. Now, the next step is verify system functionality. When you are done, when you feel that you're done, you solved the problem, you have to verify system functionality. And it used to be on the very first round of A+ that I took, in 2007, this included verifying system functionality with the user, that they felt their problem was solved. So this is going to be something to keep in mind as you verify that everything works. And this is also a place on verifying system functionality where you may have identified preventative measures to prevent this from happening again. And so this is something this is a place on verifying system functionality where you would say like, hey, and also, in the future, to avoid this, I suggest as an organization, we implement the following policies, let the user know, hey, don't do this, don't do this, don't do this, because that's what we can do to avoid the issue. And you want to definitely try and make sure that you can help in the future to reduce the scope of the issue. And finally, when you're all done, last step, document. Make sure you document. Again, a nice template, if you're following these 6 steps, is to have the 6 steps, and under each of the steps on a ticket, have a space for notes, and just tell your techs, even though that you may get some pushback if you end up being a team lead, like please put something in each of the steps, even if it's a couple words. Even if you tested your theory and had your plan of action, you executed those 2 at the same time, just for documentation, for the way we search our records, for the way we categorize our tickets, please make sure to enter something at every step of the way. So document the findings, the actions, and the outcomes. That's the general feeling there. So IET, I should probably move out of the way. IET, I, identify the problem. E, establish a theory. T, test your theory. And then it's actually EVD for establish a plan of action, verify system functionality, full system functionality, and then document your what you did. And in your documents, in your documentation, you want to document the findings and the actions and outcomes, so in the future your organization can properly handle scenarios that were solved, that you figured out how to solve in that way. I know I end up writing a lot of PowerShell, and a lot of times when I'm writing PowerShell, I'm just like writing it and fixing a problem, and like sort of in the past, I'd be on to the next. Nowadays, I clearly document what, not necessarily every line, but what most sections are doing, like grabbed all the files in a folder, get child item, boom, boom, boom. Put it into a variable, $ files equals get child item, boom. Then loop through and changed, made a copy and prepended the file name with an S dash and then the file name, boom, boom, boom. And then I could just save that script if you do it in, like, for example, the IDE, but it doesn't matter if you're doing this by saving that script, giving it a name like a script that prepends the file name with any characters, and then upload that into my SharePoint site. Now I can just go to that SharePoint site on these little utility PowerShell functions I have and just do a quick search. And then I find them and I go, oh yeah, I spent like 20 minutes figuring out all the idiosyncrasies of that once. I don't need to spend 20 minutes every time, because maybe I only have to do that every 3 months and I forgot. So I got to start over. Just having that documentation for myself, just on those little things, is really, really paid off for me. And that is what I do now. And part of that's because I've just had to redo things over and over because I don't have such a great memory when it comes to that. All right, any questions on the 6 steps of the CompTIA troubleshooting? IETEVD, IETEVD, identify the problem, establish a theory, test the theory, establish a plan of action, verify system functionality, document. Knowing the order of these and what they are, and really understanding what goes on with each one, will most likely get you a minimum of a couple of answers on the CompTIA 220-11 a 1 exam. And I have, the very first time I took the test, I missed the test. I could tell I missed it by like a question. So that can make a difference. So take the time, and that's it. So that's it for this topic. I'm going to move at the slides for the next topic. So I'll disappear for just a minute and come right back.